Welcome to my talk on harder, better, faster, stronger builds. Yeah, I hope you appreciated the effort I went into in the description of the talk with all the Daft Punk songs. I think I sort of exhausted their repertoire trying to incorporate them in. So quickly introducing myself, as I've sort of mentioned earlier, my name's David Gardiner. I help run the Adelaide.net user group. I work for a company called Auth on healthcare software, based here in Adelaide. And yeah, apart from that, always interested in the process of building software. And so this talk really draws on my experience on working on creating automating builds and deploying software, and particularly some of the difficulties and struggles I've had in doing that over recent time. So let's dive in. So we've built some software and we've created some software, and we want to be able to build it, and we want to be able to deploy it reliably. So what are some steps we can take to do that? Well, before we go too far, here's something just to keep in mind. It's a quote from Leslie Lamport. A distributed system is one in which the failure of a computer you didn't even know existed can render your own computer unusable. And we'll see as we go through this talk that this quote really rings true. There are so many times when you think you've got everything organized and planned out, and then there's some other thing you didn't even realize that fails and causes problems for you. So that's a useful thing to keep in the back of your mind. So first of all, we want to be able to build our software. There's a few different ways we can do that. We could just build it from the GUI, so from your IDE, whatever that happens to be, so Visual Studio in this case, but you could just build from there. And if you're just a single developer working by yourself, then maybe that's okay. It's only you building it. That may be acceptable, but it's not really ideal because it's obviously a manual process. Maybe we can build it from the command line. So from whatever a sort of shell that we like to use, there might be some command line tooling that we can use to build it. That's probably a little bit better because we can then start to reuse those commands and be a little bit more predictable. But again, not as good as it could be. So maybe we can combine those commands and build a script. So whatever scripting language you like. So it might be something like PowerShell or Bash or something, where we've just got one script we can run, and we're starting to get in a better place as far as being able to repeat the steps that are required to build our software. But then we can even go one step further, and there's actually some orchestration tools for our build. And so a couple of examples I've picked on here are things like Cake or Fake, which are really domain-specific languages around the process of building software. So an example of Cake, which is something I have done presentations on in the past, is a Cake script here, and Cake is actually based on the C# language. So if you're already a C# developer, then you'll be able to use the Cake scripting language and find it really familiar. But we can see that we do have some tasks here with some names, and we're able to spell out the dependencies. So we can say that, okay, if we want to do a run the test task, then that's dependent on the build, and the build task is dependent on clean, and so we've got this clean task and some actual some things that need to be taken or done as part of the clean task. So we can start to build up a dependency of here's all the different tasks that need to happen, and describe what the dependencies of one task is on others. And because it's in C#, we can just write extra C# code in here if there's particular work we need to do. The nice thing about Cake in particular is that it's strongly typed, so that all of the parameters that we're passing in are going to be parsed by the C# compiler first, so that we can catch any errors that we might have made in trying to configure our build script. Another thing we might want to have a look at is package management for our application. So really, how do we manage all the dependencies that we need to build our software? They could be dependencies on other internal components or third-party components or commercial components that we bought. So two popular Ones that I'm familiar with most are NuGet for .NET and NPM for JavaScript or Node applications, but other language ecosystems also have their own package management as well. So it's become a pretty popular way of solving this problem of managing dependencies. And yeah, so we can break down our application, even our own application. If it's a really large application, we might choose to use package management to create packages for, say, some core layer or a database layer that doesn't change very often, or it could be that component is managed by a separate team, and we could use packages to distribute that software and let it be used by other team members or our third parties as well. So we can even take advantage of that by then it means we don't need to recompile those bits every time we build all of our software, because in the case of NuGet, then we're shipping the compiled DLLs. In the case of NPM, then you're actually shipping JavaScript. But it just depends obviously on the language as to what's going to be included in the package. But there are some things to think about. So if we have a dependency on some packages, then how do we ensure that essentially the graph, all the dependencies of all those packages are the same every time we do a build? Because this is where we can run into trouble. If I do a build on my machine and at the point in time when I download all those packages, they're at a particular version range, and then my colleague or the build server tries to do a build a week later and they get some slightly different versions and things break, then that's not the kind of reliability we want for our build. So lock files are one popular way of solving this, something that NPM has had for a while, and Yarn, another NPM compatible package manager, supports them as well, and NuGet has sort of more recently added lock files as well. Something to be careful of with NuGet, and something I've run into, is that when NuGet creates a lock file, it actually will take into account the platform that you're targeting, so Windows or Linux or Mac, and will embed that into the lock file. And where that can be a problem is that if you've added packages to a solution and you've done that on a Windows machine and you haven't told it that you're also trying to target Linux, then when you go to build or restore those packages on a Linux machine, so if you're using Linux as your build agent, that will fail because it's trying to restore stuff for Windows and not for Linux. So there's some extra steps you need to do to allow those lock files to work across platforms. It can be a bit tricky because by default it wants to just use the platform you're on at the moment. Some other things to watch out for, and I guess anyone who's worked with JavaScript or NPM packages might remember the left pad fiasco, where someone decided to drop their package and all of a sudden everyone's software broke because it turns out that everybody was using that package, and the same thing could happen in other ecosystems as well. So having some kind of aggregator in between your build process and the source of those packages might be a good solution. So employing something like MyGet or Azure Artifacts might be a good idea. Yeah, that's something to think about, sort of by setting up one of those feeds and then linking that to an upstream source. It can then add some caching and also potentially save you if you've taken a dependency on a package that goes away. It also means that you might be saved from an issue where the actual upstream, like npm.js or NuGet.org, goes offline itself. If you're using an aggregator, then that may help you to be able to keep building because it's cached everything in its feed, assuming that your aggregator doesn't go offline, of course. Okay. Just intrigued as to why my menu bar is showing up. That's kind of unusual. that one. Yes, another issue that we ran into recently, earlier in this year, was that NuGet.org changed their TLS settings, so they dropped support for TLS 1.0 and 1.1. So if you had any build scripts or build processes that didn't support 1.2 and were trying to use those older HTTPS encryption, then they stopped working. And I certainly experienced this, having to update a bunch of build scripts that had been built using older versions of tools, sort of older versions of NuGet that needed to be updated. Okay, so what happens when, particularly with NPM, you've got a package that can define what versions of Node it works with. You may have seen this where, particularly because Node has what they call the LTS versions, like long-term support versions of Node. So some packages will say that actually I will only work on version, I don't know, 6 and 8 and 12, for example. And if you happen to have Node version 9 installed, then NPM is going to freak out when it tries to install that package. So this can be more of a problem when you're trying to build different products on the same machine. So if you've got some build agents and they're trying to build different things, you've installed one version of Node on that build agent, then you try and build these different products on your agent, and one thing will work and the other thing won't because they're not using compatible versions of Node. So you may have to come up with a strategy that you have different build agents with different versions of Node on it, or for each build you have to reinstall Node. It can be a bit messy. Also, sometimes the tools introduce bugs even if it's a new version. So this happened to me when you get one of their commands, instead of listing the sources, it started throwing an error. And we had some scripts that depended on that functionality to be able to list the NuGet sources, and all of a sudden they stopped working. So the solution there is really to be very specific about what versions of the tooling that you're using as part of your build process, and only upgrade that version intentionally so that you can identify, is there any problems or is everything working correctly. So in this case we ensured that our build scripts kept NuGet at a specific version until we waited until this particular issue had been fixed, and then we could upgrade to the newer version of NuGet. So even things like when an LTS version changes. So here's an example here where the documentation on installing LTS versions of Node on Linux, it turns out that the URL you get, and so this was done in my example, was done in a Docker file. Turns out that stopped working after a while because the URL that we were using didn't turn out to be a long-term URL. It changed, and so there was actually a GitHub issue here which described on how to get the actual stable URL. But yeah, that wasn't something that I was expecting to break. My expectation was that this was an LTS version, that it should have kept working because we wanted to keep using the exact same version of Node for our builds for a while. So something to be careful of. Moving on to something else you may want to look at doing is signing your application with a certificate, a code signing certificate. So in this example, an example of software that has used this would be something from Microsoft, where the publisher in this case was Microsoft Corporation, but it could be your own company name or your name. There's some issues around its code signing certificates to keep in mind if you're using those. One is who has access to that certificate. This is something you want to be quite careful of, because if anyone has got that certificate, then they can sign software and it will look as though it's been produced by you. So obviously you want to be careful who can do that. And really you want as few people as possible to have access to that certificate. Ideally, it's something you would actually just have in your automated build process so that no individual developer needs to have access on their desktop machine. The other thing about certificates is they tend to expire, and this can also cause problems when all of a sudden your build process starts failing because you forgot that your code signing certificate expired over the weekend and now everything is broken. So I guess the solution to that is really probably put some reminders in some calendars and make sure that people have got plenty of lead time to renew those certificates. And then also think about where are those certificates being used in your build process, so that you need to go and update things, or are there ways that you can have a build process that the certificate doesn't need to be checked in to the source code. Maybe it can be stored externally. So yeah, be careful of that. So we talked a bit about setting up a build server. We've certainly talked about build agents. One thing when we're setting up a build server, which I think is a good thing to do, or using a build service, is thinking about how much functionality goes in the build script and how much we use from the build server itself. So what I mean by that, if we'll jump ahead a slide, and so here we've got a screenshot of what's actually the Azure Pipelines pipeline configuration, and they actually call this sort of their classic configuration. But we've got down here some steps where we're sort of, and it's reasonably obvious what's happening here. We're installing a version of npm, then we're doing a build, and then we're creating an archive, and we're stepping through that. So that's one approach where we could sort of leverage all the different functionality that's in our build server to break down our build process and work through that. The other alternative, if you remember back to that cake file we saw earlier, would be to just have maybe one or two steps here, and the main step is just to call to our build script, and then all of our functionality is in that build script. So the advantage of using the UI is that we get all the built-in integration working for us. The disadvantage is that it now means that we can't really replicate that on our desktop. It's only going to happen on the build server. Whereas if we do use a build script, then we can hopefully use that on our desktop as well as on our build server, and it's going to be easier to reproduce the build process and be more consistent. The downside of using a build script is you've then potentially lost that stronger integration with the build server. And what I mean by that is how do you publish things like unit test results, test coverage, other build logs. So hopefully your build script has a way of reporting that data back to your build server. So that just might mean you need to use a bit more effort in your build script to be able to sort of surface that data back to the build server. So yeah, just contrasting, here's Team City, another screenshot of a popular build server, and showing that their UI. The next thing to think about is, do you use the UI? So we saw that, we'll go back, there's the Azure Pipelines UI. There's a Team City UI, quite sort of similar ideas about adding build steps in there. The other option is, can we do sort of config as code or infrastructure as code? Should we use a UI to set up our build process, or can we use something like sort of YAML in the case of Azure Pipelines and describe our build process in a file? This means that we can actually commit that file into our version control and manage it there. And likewise for Team City, for example, they have a language based on Kotlin, which is a language that targets the JVM. There's some little things to be aware of here. The advantage of doing this is that if you can commit your build process as a file, it's versioned along with your code. So that means that you can track the changes to your build process just as you can track changes to any other part of your application. In Azure Pipelines, that works pretty well as far as if you've got a branch with a pull request, then you can actually modify the build process, and that modification will take a place on that branch build. In Team City, the way that builds configurations are stored at a project level means that it doesn't actually take any changes into account until those changes are sort of merged back into your master branch. On the other hand, because Team City's build language here is actually a fully fledged programming language rather than just a YAML declaration, you can actually use language features here. So you can actually use this to sort of generate multiple build blocks and get a bit more clever. So there's sort of pluses and minuses to both approaches. So yes, we mentioned about how you may be able to use that to test out a new branch, test out a new build process on a branch. Something to be wary of though is that if you are committing your build config in your source code, particularly if you've got old release branches that you're trying to maintain, that it means that they could become unbuildable. So the example here is that we've got a build pipeline configuration for Azure Pipelines, and we're trying to build on this VM image, which is a VS 2015 Win 2012 R2. And that's all well and good. That release branch probably worked really well up until a few months ago when Microsoft stopped making that build agent available, that VS 2015 agent. So all of a sudden you can't build this branch anymore. So it means you would have to be aware of that and either provide your own build agent that has the equivalent software on it, or have to go into all your old release branches and update those build configurations to use a newer VM image of one that they've provided. So we need build agents for our build server. We've talked a bit about that already. There's two options here. One is to have dedicated agents, so that could either be on-prem or it could be virtual machines that you've paid for in the cloud. And the advantage of these is that we can basically install stuff on those machines and have them all set up ready to go. So all of our build dependencies are already available on the machine, and we can essentially cache stuff so that our builds are going to be faster. And that's really useful because we want builds to be fast. So we can cache things like NuGet packages and NPM packages and Docker images. They'll all end up being cached on the disk. But there is something to be careful of there, in that we may run out of disk space. So you might have to think about, do I need a bigger disk, or do I need to have a script that runs at regular intervals to do some house cleaning and clean up old packages or something. The other option is to use what I call transient agents. So these are build agents that are spun up just for you to do a build, and then they disappear and you never see that agent again. So essentially every time you do a build, you're getting a new virtual machine. The advantage of these is that you're really ensuring that you've got an exact sort of pristine environment to do your build on every time. The risk of a dedicated agent is that because it is leaving stuff around between builds, it might leave something around that it turns out you're taking a dependency on and you didn't realize. And it's only when you spin up a new dedicated agent that you discover that, oh, I didn't realize I was depending on this other library that just happened to be on the disk. So nothing is saved. Everything always starts from a clean slate with a transient agent. The downside of that is that we are going to have to pull down all of our dependencies every time. So that can mean a transient agent could be slower than a dedicated one. One way to try and mitigate that is to use caching tasks. So GitHub Actions and Azure Pipelines, for example, have a cache task, and what this does is it allows you to configure the task to say, okay, I've got these NuGet packages that I'm using, and I want you to, if you've already cached them, I want you to download them all in one hit. And so because it's downloading one file, it's going to be a lot faster than downloading hundreds of package files separately. And it'll put them onto the disk, and then when you get to the restore phase of your build, that should run pretty fast because it'll realize it's got all the stuff locally already. Likewise, if it gets to the end of the build and it realizes this latest build has included a new package, then the cache task will recognize that and rebuild the cache. So the cache tends to be stored, if it's in a data center or a cloud, often the cache is sort of stored pretty close by, so you're not that the download speeds are pretty fast. So that's definitely something to take a look at if you're doing a lot of downloads. So with a lot of package dependencies. So npm is a great example where there tends to be a lot of other packages that you're pulling down just to get your one package working. Also to think about, particularly with the transient agents, but even the dedicated agents, is what things am I installing, what tooling, I guess, am I installing that I need to get my builds working. And so look at using, again, ways to automate installation and configuration of that. And I guess I mean things like using Chocolatey on Windows or apt-get, and scripting that out so that you, particularly this is necessary for transient agents, but even for dedicated ones, so that you can deploy a new dedicated agent really quickly. You've got all your dependencies scripted out. So installing versions of Node or other applications that need to be on the build server for your builds to run. Another thing that we need to take into account is passwords and authentication tokens. So sometimes we might have these actually in our application itself, but more often it's our build process where we need to pass these around for the build to function properly. So first of all, be careful if you've hard-coded some of these, because that could be a bit of a security issue. And I guess it could either be in code or in your build scripts you might have some hard-coded passwords. But particularly with authentication tokens, what happens when they expire? So authentication tokens usually have an expiry. So if they're checked into your code, then that means that that code's not going to be able to be built once that token's expired. So in your build process, are there ways that you can pass in these authentication tokens outside of your build script, so that when you need to get a new authentication token, you can sort of set that and pass that in. And again, I think it's probably a good idea to keep track of the expiry dates so that you can preemptively renew your auth tokens, so that you're not going to end up with builds failing because tokens have expired. Also think about if these, particularly authentication tokens, if they were generated under a user account, what happens if that user leaves your organization? It's probably better to generate them under a particular service account or a build account that's not tied to a particular user. But yeah, just think about that, because if IT then, if it wasn't done under somebody who left, and then IT decides to disable that account, then all of a sudden all your builds might stop working. Databases. These can be a bit of a challenge. I guess there's a few different places that we need to think about databases, because our applications often tend to have some kind of database dependency. First of all, when we're creating or updating a database, how are we going to manage that? Two popular approaches. One is sort of additive scripts, where for every change we're adding another script, and then to create the database we run all these scripts in sequence. The other approach that I've seen and used is where we've got a model schema. So if in Visual Studio, if you have a database project, then that's that kind of approach, where all your tables and views are defined with SQL files, and then there's some kind of automated process to diff that model against the actual database and figure out how to change that target database to be aligned with the model database. One thing to watch out for with the second approach, I like it because you can easily see at a glance what the database schema should look like, but you do need to be careful about data loss when you're doing migrations. The tool doesn't accidentally decide to drop a column when you're renaming something or that, so you just need to take a little bit of care with that approach. The advantage with the additive scripts is you get a nice history over time of all the changes, but the disadvantage is that you end up with a lot of scripts if you've been doing that for a long time. So that can mean that eventually it takes quite a long time just to create a database. The other thing you might want to do with your sort of build and deployment process is do testing with different database engine versions. So if your application is a simple sort of CRUD application, not doing anything too fancy, then this may not be such an issue. But if, say, you're using SQL Server and you want to take advantage of some features that have been introduced in newer versions, then You might want to ensure that you've got different versions of SQL Server available to run tests against so that you can confirm that your application still works correctly. Adding unit tests is a really good idea, but there are ways that these can cause problems too, particularly when it works for you on your machine, but it fails on the build server. And one case that I've seen this happen quite frequently is around region or time zone or formatting differences, and I'll quickly jump over to Visual Studio to show you some examples of that. So just some code samples here. We've got a discount method, and we're going to give everybody a discount on Boxing Day, but the rest of the year we're just going to give them a smaller discount. So you can imagine if you're writing a test for this method, then that's going to be tricky, because it's going to work for every day of the year except for when you run it on Boxing Day. So the problem really is that we've hard-coded dates into our class. We've got datetime.now. What we really want is a way to pass that value into the test, so that we're not sort of tying it down to what is the current state of the time, essentially. So yeah, so making sure that you're not doing this where you're sort of hard coding and making assumptions around dates and times here. The second example, I've got a test here where we've got a method that's returning particular days we're going to have discounts. In this case, we've got dates, but they're actually strings that we're then parsing. So this will work fine for me on my computer because it understands the default date formatting. But if I tried to run this on a computer that was set up for US English, probably it would freak out with this third date, and possibly this second date would be not the one that I was expecting. Instead of the 1st of April, it might be the 4th of January. So again, not trying to do this kind of string encoding of dates, or if you do, being very explicit about the format and the culture that you're doing the encoding from. So this is a good one where you might take advantage. If it was in unit, for example, you might want to enforce the culture that's being used for parsing dates. And likewise, yeah, that you can get into trouble with when you've got some logic around dates and times when they forget to take into account things like daylight savings. So is there a chance that some logic in your application might run differently if it runs just 1 second before the daylight savings kicks in, and then the rest of the code runs after? I've seen scenarios like that happen, or around midnight where you're making assumptions that it's still the current day, but it turns out that the start of the method's running at sort of 11:59, and then the clock just happens to tick over into the next day, and then the test fails. That kind of test that is failing randomly, it seems, but it turns out it's because sort of dates and times are sort of confusing it, can be quite frustrating, especially if it's a test that's got nothing to do with the change that you're working on. Another thing that can affect unit tests failing could be just something like a missing dependency, something you've got installed on your computer that changes how the tests run compared to what's on the build server. So yeah, just keep that in mind as well. Or even something as simple as your desktop computer might be faster than the build machine. So it might mean things like the tests run in a different order, or that if you've got some performance tests, that those tests run okay, but they take too long to run on a build server, and so they might fail sometimes. Or it could be that using transient build agents, sometimes you might get a faster build agent, sometimes you might get a slower build agent. So there could be some variations there that could catch you out. What about integration tests? How do we handle those if we want to ensure that our application works correctly with a database? So there's different strategies there depending on what sort of data layer you're using. So for example, if you're using EF Core in .NET, there is an in-memory database provider that you could use, and that will mean that your tests run a lot faster. The issue with testing against the real database is that it's really slow because you've got to set up the database, work with it, and then shut it down. In-memory can be a lot faster, but not all the same features are supported. So things like foreign keys aren't always enforced. So it might be that you're not actually testing everything thoroughly. So I think there's still a place for full database tests. Another option besides in-memory might be like using SQLite or some other sort of memory-based database. But yeah, still have a real database test to try and test a few slices of application just to confirm that everything is actually working properly. And yeah, but be aware that that real database is going to be a lot slower to work with. Think also about how you're going to populate that database, because you probably need some test data in there. There's some different strategies there. You could load that data in each time you run a test. You could use database backups and do a backup and restore. If you're using SQL Server, then using a backpack might be a good way to do that, because it's capturing the schema and the data in that database. But there's a good one to make sure actually do some timing to evaluate each of those to see which one's going to perform best and be the most reliable as well. And think about do I want to have the database hanging around between all of my tests, or is there a risk that I might leave some data in the database and then the next test that runs will behave differently because the data has changed in the database? There's strategies around that as far as we could use transactions to try and roll back everything. Transactions don't always work depending on what kind of work we're doing with the database. Or we might just need to do a restore every time, but that's obviously going to be a lot slower. So it depends on your use case. Thinking about dependency changes, how do we manage those? So we've talked earlier on about package management itself, but then how do we manage upgrades to packages? So we could just go, yep, just upgrade everything, commit it in, push it through. One tool I kind of like is Dependabot. So if you've done any stuff on GitHub, you might have come across Dependabot. So they've actually been acquired by GitHub. You can also use Dependabot in other environments. So I've made use of that in a Azure DevOps pipeline to update some of our internal software that's hosted in Azure DevOps. The nice thing about Dependabot is it will create pull requests for each component that needs an upgrade. So then you can be confident that all of your tests have been run against that new version of that component, and that it's unlikely that that's going to introduce any regressions because you've been able to run that individually. But equally as your sort of software dependency, we also want to manage our tooling upgrades as well. So that includes things like new versions of compilers or SDKs, those kind of things, because you might want to take advantage of some new language enhancements. So source generators, for example, coming in the next version of C#, that could be something you want to take advantage of. But again, having that ability to make a discrete change and then evaluate has that broken anything else is really powerful. Also think about, do we want to be sort of more aggressive with adopting these upgrades as soon as they happen? Or do we want to be more conservative and say, oh, we're only going to do the upgrades when we really need to? Sometimes your hand might be forced a bit if there's security fixes you need to take. But yeah, something to consider as well. And then we can't really talk about building and deploying software without mentioning Docker. This has been a really useful tool that's been added to our toolkit in the last few years. The way I have been using Docker is allowing us to be very specific about our build environment. So even more so than just a transient build agent, a Docker container allows me to say these are the only things I want to have available to build my software, and so I'm even more reducing the risk that I'm taking a dependency on some other tools I didn't know about. And I can be much more specific about the versions of tools that I'm expecting to have in place to build the software. It can also let me do cross-platform builds. So I'm doing this talk on a Windows machine, but I've got Windows subsystem for Linux installed and Docker for Windows installed. So I can do Linux builds on this machine, either using WSL or just using Docker with a Linux container. And the nice thing about that is that I can then be pretty confident that then if I'm using Docker in my build pipeline, then I can be pretty comfortable that it's going to build the same way, and that any problems I have are going to be able to be replicated locally. We can also use layer caching to improve our build performance. So if we structure our Docker file in a particular way, so for things like package restores are done earlier on, then we can take advantage of the way that Docker does layer caching to mean that if we didn't make any changes to our project files and we didn't change our package dependencies, then when it's building our image, it can skip over that and reuse the layer it's already used, and then sort of move on to the next step of our building the image, which can be kind of nice. Something to be wary of, and something I've sort of run into, is if you're using Docker Compose, that's fine for running images and containers with dependencies, but it doesn't understand dependencies when you're building images. There's another tool called Dobby, which is useful for solving that problem. It does understand the build dependencies, and you can describe those in a YAML file. So check that out if you're wanting to build images that have dependencies on other base images, and so there's an order that they need to be built in. And also, again, be aware, and this is something that's just come up in the news the last few weeks, that images might not stay around on Docker Hub. Docker have just announced that they're going to be a little bit more proactive in getting rid of images that aren't being used anymore, particularly if you're not paying them any money. So be careful of that. So you might need to want to find somewhere else to store your images, or you might want to actually pay Docker so that your images stay around if that's where you're keeping your images. Caching tasks, we sort of mentioned them a bit earlier. Just keep in mind some quotes, that there's only two hard things in computer science: caching validation and naming things. Or the other variation on that, there's two hard problems in computer science: caching validation, naming of things, and off by one errors, which I kind of like. Yeah, the trick with those caching tasks is identifying when to invalidate the cache. So if you've got a lock file for your npm packages or node or NuGet packages, then that's probably going to be a good key, because that will be an indication if that file changes, then your cache changes. But yeah, that's going to vary from language and package management solution. So yeah, that can be the challenge, is knowing when to invalidate. If you're invalidating the cache too often, then the value of the cache becomes negligible, and it may actually mean that your builds are slower. Coming up, one of the other things I really like to add to my build pipelines is adding static analysis. So one thing we can do is add some security scanning, and there's a few different products out there that can do this. One I've highlighted here is the security analysis tasks for Azure pipelines that Microsoft produce. They're actually a commercial product that you pay for, but it includes things like scanning for embedded passwords in your source code, virus scanning, and checking for other sort of common risks that could be added to your application. Other static analysis we could do would be things like linting. So for example, ESLint is a popular one for JavaScript and for TypeScript. So sort of adding that just gives you that extra check that you're not sort of adopting some not so good approaches to your code. You can obviously configure that as well as to what rules you want to be applied, and create your own custom rules. And likewise for .NET, there's Roslyn analyzers. So these, again, there's a whole lot of FX cop rules that you can bring into your project, or style cop rules. You can also write your own analyzers, and we actually had a talk on this earlier in the year, creating your own custom analyzers, so that essentially at the compiler level you're enforcing particular ways that you want your application to be written. So we've built our software and want to deploy it. There's a few different ways we can do that. We could just use good old Xcopy, or just copy the file around. We could zip it up, we could create an MSI, and we might want to use something like Wix to do that. If we're shipping it to an app store, then there might be some extra steps we need to do, some validation or verification of the particular files that we need to upload to the app store to make sure that they're going to be compliant with the App Store rules. Obviously we can do that manually, but also there's tools around release management and deployment that we might want to adopt. So we could just right-click deploy from our IDE, and again that might be okay for a one-off thing, but probably having a automated process is a lot better approach. So tools like Octopus Deploy or release pipelines, or even the release process in GitHub are all more automated ways that we can set up our deployments. It means we've got the ability to do things like sort of manual approval if we've got somebody who we want to give the task to decide whether a release is ready to go out to the public, or just to track what version is in different stages or different environments. If we've got a staging or a testing environment, we can track the versions that have been deployed there and progress those through the different environments. Some issues that we can run into, one that I've come across was when the target machine was mysteriously offline. This happened to me a few years ago when I was deploying software to servers that were located out in the country, and what we discovered was that those countryside places over summer, the air conditioner got turned off to save power overnight, and we were trying to do these deployments after hours, and all of a sudden the machine would disappear because it had overheated and it would shut down. So just some unusual conditions that you don't always expect. So yes, ideally they'd leave the air conditioner on, or they'd sort of arrange for a time for that machine to be available during hours when the air conditioner was still running. Sometimes you can have issues when the server you're using might need to be replaced, so maybe it needs to be virtualized, or you might have some trouble if the hardware that you're targeting is specific. There might be some specific device that needs to run, so that could be a problem if you're trying to replace with newer hardware and doesn't have the same interfaces on it, for example. Another issue I've seen is where we had too many files to copy. What I mean by that is that we were doing a server migration. It was a newer server that we bought, and we'd calculated that it was going to take a few hours to move all the data over to our new server. What we didn't take into account was that because there were so many small files, that the actual time to copy those was a lot more than if it had been just a few large files, just because of the overhead of starting and stopping each file copy. So that ended up taking most of the day, possibly even to the next day. I can't quite remember, but yeah, think about that. Particularly even when you're deploying it, may be more advantageous to zip up stuff or tar things into one file to copy around, and then unpack that on the destination server rather than incurring the cost of the network overhead. Another challenge, and I don't really have a solution to this, is when you're doing sort of 2 or 3 nested remote desktop connections to actually get to the server to install the software. Sometimes you can come up with some strategies to sort of make that a bit easier, but it definitely means that you probably can't do an automated deploy. Yeah, that can be a challenge, especially when things are really locked down at a customer site. It's just a fact of life, unfortunately. So wrapping up, I guess sort of some key things to take away, I guess, when sort of building and deploying software is to look for opportunities to simplify. Particularly, I think over time, sometimes the build process can evolve, and just like the rest of your source code, if you're not looking to refactor that and simplify it, then it can get a bit out of hand. So trying to aim to have a build and a deployment process that are as simple as possible and just makes it easy to understand and easy to maintain. And yeah, sort of thinking about if you're sort of into lean thinking, the idea of reducing waste is also a useful thing to keep in mind. So an example of waste might be that you're rebuilding the same thing multiple times. Are there ways that you can avoid doing that extra work and just doing that work once? Looking for opportunities to automate and yeah, sort of reduce the risk of manual steps and making mistakes in those manual steps. Also iterating over that sort of, we've got something running, keep doing it. Are there opportunities to improve that and learn from that? And particularly incorporating feedback. So both in the build process, that we're getting the right data back about our build, and if something fails, that we've got a useful error message that we can act on. But also when we deploy our software, have we got ways to get feedback on how that software is operating in production? Was the deployment successful? Are there errors in production? How can we act on that? So yeah, I think if we can do all those things, and then we're well on our way to having a better build and deployment process. For myself, these are, I wouldn't say I'm there by any means, but these are things that I'm aiming for and sort of learning more over time.